All right, we have Eliot for the fourth time, and then the long-awaited AJ that we have been searching long and deep for to get on this podcast.
I have been avoiding you for I don't know, maybe a year now, I think, right?
More than that, absolutely. And it was actually Eliot that got you on here.
And not because I dislike you. I am just not really good at these. I think I've done maybe in 27, 28, 30 years I've been in this business, I've done like 3 of them. So this will be a 4th. And yes, Eliot convinced me to do it. He says it only hurt a little bit. So here we are.
It's going to be painless, trust me.
Good to see you both. Here we are. And, let's hopefully it'll be informative and a little fun at the same time. So
yes. Well, I was thinking about what topic. There's 1.5 million topics we can get into, and it was AJ's idea actually to dig into the domestic American-made unitized glazing systems versus the European-style glazing systems. And it's actually perfect to have Eliot on here too, because he's probably worked on a bunch of projects with you, either in the investigative side or testing side, in dissecting some of the issues in both methods via those systems. But I'm going to go back to what I brought up before. I do want to hear where the two of you met.
So you want the Genesis story?
Yes.
Okay. Eliot, you want to go first or should I?
You go.
Try not to age us, whatever you do.
Well, that's going to happen.
So anyway, long story short, I hope, Eliot and I are the next bastion of elderly folks in the business. We've been in the business now long enough to say, before we were the young whippersnappers, right, Eliot?
Yep.
And for whatever reason, I don't know what happened, without my permission, now we're becoming like the old folks, right? The old school. And sometimes it's not even for the better. Sometimes it's for the worst.
Oh, trust me, every morning I think it's for the worst when I get
I'm going to need to mute myself because I'm going to be laughing.
We're surrounded by extremely, my favorite line was, the good thing I'm extremely technical, the bad thing I'm extremely technical. Well, I'm not feeling as technical anymore I think the young bastions in this business and the technology has far outpaced me. But anyway, so how, that's for another time. How I met Eliot. So Eliot and I met, I think, going back now 25 years maybe, something like that. Yeah. If I was going to be tested, I would have studied. But anyway, yeah, a long time ago, he was in the window business and I was a young whippersnapper, inspector, working my way up to being a consultant at Israel Bergen Associates.
He was a senior consultant.
No, well, I don't know. Listen, you got to all start, and don't get me started on that one. That's for another podcast. I was training myself to be a consultant, because to be a consultant, you can't just do it out of a book. You have to have experience, right? So I had some experience, but I didn't have a lot of experience, right? So that being said, I met Eliot. He used to pop in and out of our office and meet with some of us, and we get along really well. And ultimately, a few years down the line, for whatever reason, if I'd known then what I know now, I would have told him not to. He wanted to become a consultant. So he became a consultant. He came to work with us. I actually welcomed it, because Eliot's knowledge of Windows, even now, is bar none way above most. All right, so
I'm trying to convince him to go back to the consulting side, but he doesn't want to listen to me.
Well, you have to be a bit nuts to do it. So and I get why he doesn't want to.
I like to say passionate.
Yeah, I would love to spend the rest of my career at a testing lab. But that's
the door is always open.
You know the whole saying, the grass is greener on the other side. Well, in this case, the grass is greener on the other side of the window that has low iron glass, right? So, and anyway, so he came on board, and I was really excited, because I like to surround myself with smart people. Always have loved to do that. Sometimes I'm successful, sometimes I'm not so successful. But he came on board, and then something mysterious happened, that we started competing. And I'm going to say for a short period of time, we became enemies. Enemies in the respect, not frenemies, I guess is what the young people say these days. We were frenemies. We were competing, jockeying for that position, the consulting positions in IBA, Israel Bergen Associates. And then after a while of butting each other's heads and butting our own heads against the wall, we realized that at the end of the day, we were too much alike to really be angry at each other. So if I remember correctly, I took a hiatus from Israel Bergen Associates, and so did Eliot. I made a mistake of coming back. I think I got married. That's why I took a hiatus. And then I came back to the consulting world, came back to Israelberg and Associates, and by that time, Eliot had moved on, and I'm not sure where you went. I think you took a hiatus from the business, right? Having a couple restaurants here and there, and
Yeah,
so
it
you
was
know,
right
I
after
used
the Black Monday. Stan Chan, who was also an old IBA guy, Stan went into a Chinese restaurant, and I decided with my years of culinary training to open up a Mexican takeout place.
yeah.
Because we both
Take
swore.
that all in. Eliot Benor, taco extraordinaire.
I'm so happy I'm recording this.
So you wanted the Genesis story. You got it, baby.
This is fantastic.
It was 9/11 and the market crash and everything else. And after 9/11, I was like, oh, they'll never build another high-rise building in New York City again. If they're crashing planes into them, who's going to go to work in a high-rise building?
Little did we know. That. I got one even better than that. So Eliot and I always stayed in touch, regardless, right? Yeah. And I used to call, in those days, him, and I said, you know, Eliot, I have this desiccant problem, and, you know, the edge deletion, whatever. I just bring up issues to him, and his response was, I'm not sure whether I should put that extra salsa in the taco. It's not selling as well as it used to. So I have to reel him back, and he did.
All right, so I need to reel the two of you back now. So I realized we're not even going to talk about facades. So when you were both at IBA, what was your specialty area? Were you jack of all trades, or were you focused on brick, precast, curtain wall, window wall?
AJ was the unitized guy. I mean, without a doubt, he had the most experience. He had the most knowledge, the most hands-on with the unitized. He was the unitized guy in the whole office. Him and Bill Logan, really, all the jobs, all the major jobs were either going to both of them. They worked on jobs together. AJ was the king of the glass facades.
Well, I had a tendency to steal Bill Logan's jobs, right? So he's one of my mentors. There's a few in the industry that I really hold very high esteem for, Bill Logan being one of them. And he was a great designer, great inventor, but really wasn't fond of carrying the job through. He wanted to basically finish the designs and hand it over to someone to make real. And that's when I realized that. Yeah, and I realized that early on. I said, you know, if I just hang around this tree long enough, every time a fruit falls, I can actually just take it. And that's how it started. And unfortunately, that byproduct for that was not only learning a lot from Bill and in general, getting really interesting jobs, but getting interesting jobs that were overseas. And that's kind of, I say it was a slippery road because I was responsible for the international projects, most of them.
He's totally underplaying this. It was the largest projects in the world him and Bill were working on. Like the tallest building in the world, the biggest projects in the world.
Did we not start this with, I'm not good at self-praise? Anyway.
You didn't do it. I said it, not you. And I did replacement windows.
Eliot was the expert at window. Whenever I had an issue with windows, I mean, let's face it, everybody thinks that windows are easy, right? They're just an opening that you lock and you open for air and so on. Windows in our business, there's a few other items, but windows in our business are one of the hardest items to actually get right because they change from project to project. The requirements do. There's a whole bunch of, you know, between liability and functionality and user groups and so on and so forth. They're the hardest thing to actually get. And it used to be the famous line that Eliot and I used to use. A curtain waller is good at curtain walls, but they don't do windows, right? A window guy is good at windows, but they don't do curtain walls, right? That was the old school mentality. And when a curtain waller needed a window, guess what he did? He went to a window guy to get a window to put in his curtain wall, vice versa, right? That was the world. So whenever I needed advice on hardware mostly, and on some windows in general, I would call Eliot. So Eliot was really the guru in the office when it came to windows and the operation of such, and segueing into the whole the European versus American windows and the whole gamut. I would actually call him first, and I still do.
People also don't have context about your time at a world-renowned architecture firm, so I think you need to add that in too before we go into specifics.
Well, that's a plug. So that's part of my history, and it's a long one. So I, after many years of Israelberg and Associates, I had some personal issues and agendas that I needed to take care of. So I decided that I needed to do something other than being in New York. Working, I had been traveling the world. I was on a plane almost every week for years. I remember one time counting 60 red eyes to one country alone in 1 year.
AJ's famous saying was, I've been to 20 countries and all I've ever seen is the airport, the job site, and the hotel.
No, and the conference room. Don't forget that.
And the conference room. Sorry.
Right. Like, I've been to some countries and people say, oh, did you see this waterfall? I was like, are you kidding me? No, but I know where the terminal is. you know? So anyway,
That was every week we'd talk to each other and I'd say, how was it? You were in Paris last week. He says, I really wasn't in Paris. I was in the airport and I was in XX's office and that was it.
so, yeah, I mean, so I left. Basically, I decided that it was creating havoc in my personal life and my marriage and so on. That I couldn't travel as much as I mean, literally almost 1,000,000 miles in a year is a little too much, right? So, so I got a call from a pretty renowned architect, right? Frank Gehry, and he asked me to go play with him. And I saw an opportunity to not only, you know, facade guy working for Frank Gehry or on Frank Gehry projects is like, you know, it's like a playground, right? I mean, it's pushes you to the limit. Frank has known to push everything to the limits, not just architecture, materiality, everything, right? So for me, it was a problem because I was by that time I was a partner in Israel Bergen Associates, and you know I didn't know what to do. And then my wife basically told me, she's like, you know, listen, you have an opportunity to kind of right the ship between your personal life and your professional life. This might actually be something that is an offer that you don't get again. So I took it. I went there. Fast forward, my daughter gets older. We need to go back to New York for, again, personal reasons. And, you know, I did come back to New York and work for Frank on some of his jobs for a while from New York. But then, you know, the phone started ringing. And they said, you know, I had local clients saying, I hear you're back. Can you help me with this and that? And I told Frank, I said, Frank, I don't feel comfortable just working on your stuff, particularly since you're paying me. I got other people calling me. So we made an arrangement, and you know, and that was the genesis of the beginning of this company. You know, that was 11 years ago now. And we've grown, and you know, I still stay in touch with the Gehry folk, some of them, you know. Anyway, that was a progression. I'm not sure why we kind of sidebarred on this, but
well, we went there because some of the Gehry projects have some of the most abstract facades I've ever seen. I mean, I did a video of that sailboat looking building on the High Line. I don't know if you worked on that one, but were you basically a designer, a kind of technical in-house technical consultant?
No, I was like every other consultant that I know is good at their jobs, and I'm not saying I'm good at mine. I try to be. I've been a marriage counselor, psychologist, engineer, lawyer, mechanic. You have to be everything to get these jobs to happen. And the misconception is that Frank Gehry's cutting edge stuff has never been seen before. He has a very uncanny ability to take the normal and make it special. I mean, it starts at his house, his original house, because he now has a new one, right? And basically, like he said to me, he's like garbage construction. You know, he took everything that everybody thought was garbage, chain link fence, corrugated metal. I mean, anybody said corrugated metal, the first thing you thought it was a Butler building or a favela in Brazil or and he actually took it and made it his own, right? So he's known to take that, you know, standard materials and literally twist them to a very refined approach. So anyway, yes. So I moved there, and yeah, the long story short is that I moved there, and then I continued to do traveling. So I traveled. I did jobs for him in Australia, Abu Dhabi, you know, China, I don't know, a bunch of other places. So the traveling was continuous. And that is why when we talked the other day, I figured that we might actually want to talk about some of the differences, which brings us right back to the topic.
So I want to cut in real quick for a story. Adrian, you're talking about the IAC building on the west side of Manhattan, right? So AJ was the facade consultant on that back then top secret project that no one in our office knew about other than him and Israel. And he's calling me from the lab in Italy because that job was fabricated or at least the mock-up was fabricated at the plant in Italy, right, AJ?
It's actually yes and no. There was several mock-ups. There was a mock-up done that even I wasn't privy to in Florida. And this was a proof of concept mock-up. And they literally didn't tell anybody. There was a design assist guy named Mike Budd, who at that time worked for Permis de Lisa. Mike Budd is another one of, he's not a mentor because he's on the manufacturing side, but it's someone I hold very high esteem for. He's very, very bright.
Yeah, one of the pioneers, for sure.
Right, so
But AJ's calling me. Sorry, go ahead.
Go for it.
AJ's calling me, telling me this thing where they're laying out the anchors and they're bending the panels in plane to get the angles that you see on that building. That is one of the most unique jobs, and especially at that time. You talk about cutting edge. That job was beyond cutting edge back then. They were
Well,
literally
there's a
cold
reason why we
forming
get
these
to that
panels.
point, by the way. It's not as romantic as that. It's very, like I said, they take standard stuff and make it special. So the shape of the building, obviously, because the client was Barry Diller, was sails. Right. That was the idea that Frank came up with, because Barry Diller loved sailing. There was sails, and he wanted to introduce that into the design. And we came up, the original concept was to do slump form glass, which can be a different topic for a different day, a very long discussion. Anyway, that is expensive, and the number of types of typologies for that job would be, orders of magnitude 6,000 to 7,000 pieces of different forms. There's some,
and Fritz and everything else.
right, there's some science between, in Frank's geometries, that they have to have a ruling line, for those who are geometrically interested. And anyway, so it was just financially really just over the top to be slumping glass, 6,000 pieces of glass, different size glass. So it's my understanding, I wasn't there, but the genesis moment for that was that someone actually saw, they were had a meeting at a job site, and someone walked out and saw a piece of glass on a table, an insulated glass unit that was being replaced on a table, but it was hanging off the edge. And it was slightly bending. It was, the aspect ratio of it was 5 feet by 12, whatever it was. And it was slightly bending. And someone said, why don't we just try to cold bend the glass? We can manufacture it in a certain way and cold bend it into, so that began a 3-year intensive study on what we could and could not do. I mean, I personally, and I was I was in the middle of all of this, and I was losing sleep. So can you imagine the people that were actually doing the work, right? And then what we found out is that if you take
on site, they cold formed.
So what we found out a bunch of things, right? We found out that when you actually structurally glaze a piece of glass onto a frame, and you try to bend it like that, literally forcefully bend it, that the stresses of the actual bending go to the corners. So the trick was to make the I modulus of the framing deeper, so it would actually the aluminum members on the back will actually take that stress of bending it, right? So now I'm telling everybody the secrets. It's been up for a while and it hasn't fallen down, so I guess it's safe for me to say that it worked, right? And then what we really found after all those years of studies and actually prototyping and putting it up, we found out that the geometry of the building was such that when you set the panel on the actual building, in this case we found out in the mock-up, that the orientation and the weight itself of the unit would already give you 3/4 of the bend you needed anyway. You didn't have to push it in. It actually kind of naturally fell into the anchor. I don't know if you guys get that, but it was a nice and pleasant surprise that we didn't have to force anything, because at one point we thought we were going to have to muscle it, and it has its own discussion for an hour if you guys want. I don't want to get into, the shear of the silicone and longevity and the dead loads, and it's a whole long discussion. But yes, that building was fabricated in Italy. And the glass was fabricated. We had to go rounds with the glass, and we went to 3 or 4 European countries, and which is part of, again, takes us back to the topic of European manufacturing versus the U.S., which is also different than U.S. manufacturing to Asia or Asia manufacturing to Europe. I mean, and there's new emerging markets of manufacturing as well. So
it was that time, especially when you were doing a lot of work in New York, was all the unitized work you were focusing on from the big domestic suppliers like your Enclose, Benson, Perma, and so forth, or were you seeing a lot of overseas systems at that time?
Well, it's funny. It depends on the time of my career, because there was a time where I was very New York centric, and then I started traveling, and then I was responsible for most of the international work. So I spent most of the time outside of New York, while the rest of the office would focus, not all of it, but would focus on New York centric projects. And then the crash came. One of the crashes, because I've been through a few cycles already. Things got really bad, and all the manufacturers, the New York centric manufacturers, started chasing me around for work outside of the U.S. because they couldn't find any work. So it really depends. When I was in New York, heavily involved in some of the stuff in New York, it was the Harmons, the Couples, the Encloses of the world, Benson. I've done work with Lisa, Glassaloon, all of them. So I worked with all of them.
You didn't have options to go to Cornier and buy a unitized system back then. Those guys had the unitized systems they designed and made themselves. Everybody else was doing stick back then.
Yeah, so the infancy of this business starts in the 80s, right? Of unitizing / panelized, which is slightly before my time. And I kind of stepped, and I think Eliot as well, we stepped into the business right as people were saying, this really works. So let's push it. Let's go more unitized. Let's go bigger. Let's do more geometries. Let's, we can structurally glaze glass in a building without having it fall off. The industry was getting confidence on what to do. Because before that, it was, Conair 1600 stick-built system with pressure plates. And I mean, we in the business know what that was. And that we kind of got the opportunity to see this whole industry flourish.
Well, also what I think is kind of interesting, which Elliot can kind of chime in on given his experience at Fulton, is now let's just look at North America. Why, when you go up to Canada, you see the bypass concept, where that's not kind of business as usual here when it comes to window wall systems and setting windows from the inside or the interior window wall, rather, where that came from, the concept of a bypass system.
Well, that was just, I was actually around when that idea came about. It was a guy from Soda, Juan Speck, who no longer owns Soda. But he, before the hybrid, which what you're describing in those days was called the hybrid system, I went up to Canada to do work with him on to do inspections and do some consulting work for jobs that I had with him using his curtain wall system, which was the Therm 3 is what he called it. And in those days, it had just went from, it was called Soda, but just before I started working with them, it was called state of the art. That's what Soda comes from, right? And he had bought it with some other people from someone else, and wanted to legitimize it. So anyway, he didn't understand window walls. Not technically understood them. He didn't understand how window walls were efficient, right? So, but he also understood that the New York marketplace has this, and I think it's changing now, but has this mentality that window wall is what we do here. It's less expensive. It's what we do. It's a safer choice. That's what we're going to do. And he, rightly so, said to most people, I don't believe that. I believe that a curtain wall is much more efficient, faster, cleaner, able to do more. And on top of all that, less labor on site, right? Because a lot of New York stuff is driven by was driven by unions and labor costs, right? So he took his Therm, all that a hybrid system is a Therm 3 curtain wall with a notch out of it that actually allows for the slab to be nestled within the frame.
Right, but it allows you to do it from the floor. So now all of a sudden you don't need a tower crane.
That's correct. So, but again, if you were to move the slab back, whatever, the 6.5 inches, 7 inches, and add that notch back into the curtain, the frame, it's a curtain wall. Right?
So wouldn't you make the argument though that window wall is more labor intensive?
All day long. I truly believe that window wall, I still can't understand. Maybe I'm just not smart enough to figure it out, but I've tried to figure out why window wall is cheaper than curtain wall. And when you take it all in, because a pound of aluminum, as Eliot will say, is a pound of aluminum.
Right.
Manufacturing a frame is manufacturing a frame, whether it's, 10 inches shorter than a curtain wall by being a window wall, you still have to do a slab cover. And the amount of labor and different trades that are involved in putting in a window wall, still can't understand why a curtain wall will be more expensive. I think it's basically because it's always had this perception of fancy.
What, a curtain wall?
Yeah.
So why is window wall so popular here in New York if we have such high labor rate markets? And I've been in other markets with AJ where they don't grasp the concept of window wall.
I know. I don't know. I can't honestly say. I have my suspicions, but they're just opinions. And, everybody has opinions. I don't know why in New York it is so. I would think that, Eliot, maybe you can agree to this or disagree. In the old days, the window walls that we knew were like the EFCOs of the world, right? Traco, EFCO, all that. I think they came up with this and put so much of it in at one point that it became a standard, maybe? I don't know. What do you think?
What people were comfortable with, and they knew how to do it. And there's a lot to be said for comfort and familiarity. But as far as efficiency, if I never had to drill another 1/2-inch hole over my head in concrete and hit rebar, I'd be a happy person. Because every window wall that's out there, none of them use embeds. They're all drilled anchors, right? So you're drilling holes either on the floor slab or overhead in the bottom of the floor slab.
Into a no-fly zone.
If you can get a no-fly zone and if they actually get it right. And it's the worst. It's the worst. But so many people are so used to doing it that they look at it as just, that's how we do it. And unitized is, you have an embed, you put a half an anchor into it, You twist it, you set your P-clip, you're done. Move 5 feet over and do the next one. You don't have to do anything on the underside of the slab. It's so much more efficient. It's so much more efficient. But people needed to differentiate themselves. And I think that's where Soda's Therm 3 hybrid system came from. It was not a generic unitized curtain wall anymore. It was a product that they could get architects to spec into jobs and say, hey, we make this. This is the benefits. You don't have to fire safe. You don't have to do this. You don't have to do that. Which, listen, fire safing is an actual expense and a cost and an issue on jobs. So that system really eliminated fire safing between slabs, at least when it first came out. I'm not sure about today.
Well, with a unitized curtain wall, do you run into issue with cantilevered slabs and having to deal with terrace conditions and that full integration?
That's exactly that's an Achilles heel of the unitized curtain wall.
Absolutely.
And I was blessed to be around when the hybrid was literally developed, the birth of it, because I was on the first job it was ever used, right? And it was such a success that you know, he literally capitalized that for. I mean, I remember a period of time in New York where every client came to me and said, I want a hybrid system. And I think it was just marketing, because at the end of, again, I don't know how many times I can say it. It was a curtain wall with a notch out of it and a different anchor. That's all it was.
Absolutely. Absolutely. It worked well. It worked well. It works well. I guess they still produce it, right? But yeah, it was, listen, and that's the key to our industry also. They didn't just, AJ talked before about the IAC building and the amount of time they spent developing it, literally years doing mock-ups and research. Soda didn't come out with Therm 3 in 6 months. Believe me, they didn't. It was more like 3 years. And that's the key, is developing it well, really testing it, really putting it through its paces, getting input from all sides of the industry, designers, installers, people in the buildings afterwards, and then using that to really get a fine-tuned system that when it hits the market, it's going to succeed most of the time.
Well, AJ, when you go to Europe, do you see that slab-to-slab window wall with a slab bypass, some type of slab edge cover?
Believe it or not, I do, but not as often.
Really?
Right? I do, and the reason being is because now the Europeans are heading towards what they call outside and inside living, right? So there's a lot of balconies, winter gardens. They call them all sorts of fancy names, but basically what it is section of your, and more in residential than anything else, there are sections of your home and that is actually outside that can be enclosed in the winter if you really wanted it to, and that obviously lends itself for window wall and not curtain wall, right? So there's a lot of that going on, and again, the problems are when you transition, because it's sometimes a hybrid of the two, window wall / curtain wall, and you get into trouble because we all know that curtain wall works on stacks, continuous stack joints, and the more continuous and level you have a stack joint, the better the building works, but you know, not when you have start stops. So yeah, the Europeans are, it's actually kind of funny because it's in reverse. We are starting to realize that curtain wall might be as efficient, if not, I'm going to go on a limb here and say less expensive than window wall. People are starting to understand that might actually be a reality here. And in Europe, they're saying, you know, we've done curtain wall for a long time, never on residential, but now all of a sudden we have residential, but they are more in tune with the whole, I mean, the whole environmental movement started in Europe. The Germans actually are at the forefront of trying to make everything as energy efficient as possible, right? So on top of all that, they like the quality of living to be a certain way. So yeah, they're actually looking at window walls for different reasons than being efficient.
You guys stumped me. Now I'm trying to. There's so much.
That's a lot of. I mean, we can talk forever.
I know.
You can make a season 2 or, you know, series 1, episode 2 or whatever. I want to talk about manufacturing. If you don't mind me, and so does Eliot, because Eliot and I love manufacturing, right?
I don't know if I love it, but sure.
Yeah, oh, I know. So let me, and you can cut this out if you want, but whatever. But I you know, 25 years ago when I was first starting going to Europe to see some of these systems, and in those days it was like, ooh, we're getting a European system here in the U.S. You know, let's go see what it's all about. And they weren't so, you know, now you throw some of these names out there which have been around forever, and they were like, oh yeah, that's a European system. Yeah, we've used that before. But in those days, you know, Schuco, you know, no one knew what Schuco was, including myself, right? But it's $1 billion company. right? They do work all over the world, and they spend more money on engineering than anybody could ever guess they spend. They spend a lot of it, right? And which a lot of Europeans do, right? And that's the genesis of the difference, right? So I used to go over there and I used to see these guys in lab coats at the shops. It's a real disparity way back when, where I go shop in, say, Germany, and I see these guys in lab coats with pocket protectors and micrometers in the hand, and they're doing all the aluminum work, and and then I go to a manufacturer here who's no longer in business, and I go to their shop, and the guys are running around in flip-flops with hacksaws, like silicone riddled tape measures. I mean, so that's the disparity, or that was the disparity back then, on what I saw, and between the two manufacturing processes. Now,
fine. So you're in Eliot's test lab, and you're testing punched windows. 10 out of 10 times, testing a domestic system or testing a European style system, which one fails more?
I can't answer that, because
Meaning,
I don't know.
to that question, do you attribute it to quality, the means of assembly,
And
the
that's why I
principles
can't
of how
answer
the
that.
system works?
Yeah, that's why I can't answer that. There's so many, and Eliot can attest to this too. There's so many factors on getting something to perform correctly that from job to job it could change. I mean, you could get a wonderful system, whether it's European, Asian, US, and do such a disservice shipping it, installing it, and sealing it that it's going to not perform well, or for that matter, someone here doesn't understand it on one job, and then you get a different installer on the next job, the same system, that performs like nothing has ever performed as well, right? So it's not a specific, you can't put a scarlet letter on one specific system. What I can say, and this is a shameless plug for our business, is that you need the third party with experience to know, have you seen this system before, and what has worked and what hasn't, to make sure that it's successful, to up the chances of success. But for me to say, well, this one, the Europeans pass more than the US, that's not true at all.
No, it's not that. AJ's absolutely right. So the European model is different than the American model, and it starts with who's a fabricator and who's a system designer. So in Europe, you have Schuko, like AJ mentioned, and a bunch of other companies, Wacona. We could go down the line.
Reniers. There's a bunch of them, and they're all big.
And they design the system and then sell a program to a fabricator that's local in a town in Italy and services that town, right? So they give them all the technical support and everything, but they're dealing with people who make 5 windows a week that fabricate it in a garage and install it, and then people who make 1 million windows a month and are doing major convention centers in Egypt, right? That's their business, is just to design those systems and set people up to fabricate their systems. However, everybody has a different level of expertise, and their products are going into different markets. We just completed a mock-up with a European, actually a German system, very high quality German system, with a good fabricator that we like, and they had a difficult time. But they learned during the process of the mock-up what they needed to do to achieve true pressure equalization, so that the European system with the European design was performing the way it was theoretically meant to perform. And that's stuff that they can't teach you at a 1-day seminar or even a 5-day seminar on how to fabricate their product. When you say, is it European or American? We have European companies that never miss. They pass every time the first time. And then I have European companies where it takes us 16 tries to get it to pass. And it's a stupid quality control issues. And we have the same with American companies. Very few can I say, oh, they never fail. And after this year, we'll be able to say that about one less company, because we just found out a couple of weeks ago that Apogee is closing Warsaw, which is a blow to the old timers like us, because I mean, we grew up on Warsaw windows.
That was a staple. That was, when it came to American manufacturing, that was the staple for us. I mean, we went for, if you wanted something, no disrespect to Skyline, but if you wanted something that was on borderline custom and borderline and like everything else, nothing's perfect in life, but if you wanted something secure in what you were building with respect to windows, you went to Warsaw first.
Yeah, ironically, I mean, yeah, to the Skyline, between Graham, between Warsaw, a lot of these had a lot of collaboration in the early days, 30, 40 years ago, between designing a lot of, the original 97 series and all those windows. Was a collaboration between the parties.
Yeah, I've been in this business long enough to know that Skyline was at the forefront of European hardware here in the States.
Yep.
You guys offered European hardware and Euro grooves, for those who know what a Euro groove is. before most everybody else. They actually followed the skyline approach later on, and later on in my career. But when I first started in this business, Skyline was one of the forefront American manufacturers that used to introduce European high-end hardware.
So Eliot, probably on 4 out of the 5 podcasts he's been on here, he makes this joke that the windows are now basically plastic windows with aluminum covers, just given how big the thermal breaks are. So all these European systems with these big thermal breaks and trusses and so forth, do you see any issues with them performing structurally in larger sizes under high design pressures?
100%. Yeah, we are pushing, the industry is pushing the limits of a good idea to the point where it might become a bad idea. Not yet, but it's, they're pushing the limits, like, everything. And that's the approach that the Germans have taken, at least with energy. They think, I always say that the joke for me is the American engineer and the European engineer have two different mentalities. The European engineer kills himself to take things out of the design and make it work, where the Americans, if it gets too complicated, add to a design to make it work. Unfortunately, the Germans have taken that approach with energy, right? They think that by the making the building more energy efficient, the only way to do it and to get there faster is to add things. So I've seen hyper insulated approaches from the German market where you see 18-inch thick insulated walls. I mean, it's just totally out of control. It looks like an igloo, right? And that translates throughout the whole thing: the glass, the coatings, and thermal breaks, everything else. So yes, they are pushing a good idea to the realm of could potentially have a byproduct that's not good.
Well, does that also translate to glass and how big we're going and the different spacer materials and how that's going to perform in time?
And that's been going on forever. And Eliot probably could speak better to that. But I mean, I've seen so many new ideas through my career that became old very fast, and some of them really didn't work very well. I mean, I remember the first insulated glass units, when I did some forensics, where they didn't even have a spacer. They took a piece of glass and they bent it into a U shape. Yep. I don't know if you remember those, Eliot, and that's going way back. Right? That is the first insulated glass. I mean, that's the one that they used to use for caves. That's how old it is.
The UN still has that glass in a big part of the building. The original thermal pane.
That's when I saw it. And then they went to, then the warm spacers and different types of spacers and corner keys versus bent and, edge deletion, and then the new coatings involved. So yes, the glass has its own little animal, and I don't know if it's ever been corrected, Eliot, has it? I mean, we continue to see issues, quality control, quality assurance issues on a lot of the approaches, even if they've been used for 20 years.
True. Yeah. Okay. So if that's the case, then you have concerns about a standard IGU just in certain sizes. What happens when you start to introduce all these new fiberglass protruded systems and UPVC and window wall? I mean, things I've never heard of. Do we know the long-term ramifications of trying out new systems in extreme conditions?
It's funny you mentioned that, because they were trying to do that when I was your age. When I was young, they were trying. Protrusions have been around forever, but just not here, right? The Chinese have used protrusions since the mid 80s. And the issue with protrusions, I'm just honing because there's carbon fiber, there's all sorts of other things that have been tried. And believe it or not, I've been blessed to be able to scientifically get involved in trying, even though they've never been applied to a job. But the issue with these protrusions and carbon fibers and all has to do with heat, because from a weight to strength ratio, they're far better than aluminum. And I'm not sure carbon fiber, but I know protrusions are better for the environment than aluminum. It's less of an energy hog to make. But they were always like the cutting edge. Let's do this next, but it never really took off for whatever reason. Now I'm hearing you saying that this is a new thing. Well, it's been a new thing for a long, long time. It just never really has gotten any traction yet.
I hear people talking about it. It's a marketing scheme, or you hear it brought up every now and then. I don't see any actual implementation. And I actually had NSG on the other day, who's been doing vacuum glazing in Japan for decades. And they say we have new construction multifamily buildings with VIG that have been up for multiple decades. And so you have this technology that's been implemented in a large scale market successfully, yet here stateside, they see, unless we see a use case, we don't want to hear from it.
I've got one further than that. I was involved in a study of a project that never got built, and I won't say because I don't know where the technology is going to go, but it was a design that contemplated using carbon fiber for framing, canopies, structural members, 20-meter cantilevers, really crazy stuff. And they liaised with Boeing, the airplane manufacturer. It's probably not a good example of what's going on today, but ultimately Boeing was all for further developing their carbon fiber technology. As you know, they make airplanes out of it now, right? So we got really deep into that rabbit hole. And for whatever reason, the job was never, the designer wasn't selected, the concept wasn't selected, but it was eye-opening on how long carbon fiber has been around and how little it's actually being studied to be able to use in certain. And I think from there, they were already working on carbon fiber airplanes. So it's not like we were on the moon. We were kind of like on Antarctica. We were on the same planet, but it's not common. So yes, all of those things that you say are really cutting edge, they've been around for a while. They're just some of them, and it probably has to do with revenue, right? Does it make any money or it doesn't make any money? I mean, that's the whole idea with custom versus standard, right? I don't know of any custom company that's truly can say that they've really made a lot of money in their history, right? They love the art and they make a living, but I don't think these ultra custom guys really, are financially as successful as mass production.
So all I've really heard you say in the differentiation so far between American versus European market is A, they take this additive approach to energy efficiency where just bigger thermal breaks, more insulation and more. And then B, they have this sort of separation or distinction between system designer and fabricator and then installer. So they're sort of designing and helping this person, whatever scale it is, to build or deliver the project. What about in the actual design of the system, and then positives or pros that us domestically can learn from the style of European aluminum systems?
You want to take this one, Eliot? I mean,
Sure.
I have some comments, but let Eliot jump in here.
I think the Europeans look at the overall system and really design every part and piece very, very methodically and logically. So where we will look at the aluminum part or the framing part of the system, they don't just look at that. They look at every injection molded part, every gasket as an opportunity to make it more efficient thermally, production wise, and they do that. One of the things that we don't talk about, European systems are designed to be built with 1 or 2 pieces of equipment with a minimal investment in equipment, right? You need a miter saw. You could assemble them without a corner crimper. Most European windows are 45-degree cut and then joined together either with a crimped corner or the new mechanical attached corners, right? In the United States, we cope the corners on most windows, not all, but a lot of the double hung sliders, fixed windows are all coped corners that are fitted together and then screwed together with screws into screw bosses. In Europe, they don't do that because their market was smaller fabricators with limited space, limited budget for equipment. And here you have the mega manufacturers that AJ mentioned, Traco, Warsaw, EFCO, Graham. These are 1 million square foot warehouses with budgets for machinery. And, that's one of the major differences.
So you're saying the Europeans are mitered and crimped, where domestically a lot of them are just screwing the frames together?
Yes.
Yep.
We cope a lot of
and so the crimping would give you better performance, right?
It depends. It depends how you're crimping it, the design. But getting back to the original question, they look at every aspect of it. So here to make an injection molded part that suits, a lot of times they'll see if an injection mold that has a standard part that they can adapt. And Europeans don't do that. They really look at everything and say, this has to work precisely. And there's a lot more government incentives in Europe to set up more manufacturing than there is here. There's an overall,
it's a perfect segue. Perfect segue to add education. That's what Eliot's trying to. The message he's getting across is that there's a culture in Europe of education. Not everybody here graduates college and says, I want to go do apprenticeship at a shop for 6 years, right? There's a culture, and they don't even have to go to college over there. You can actually, you can go to, let's pick Schuco, for example. You can go to Eccles or Schuco or any one of them, and you can take their apprenticeship course, which pays you a little bit of salary, and literally instills a new foundation of their mentality, whether it be engineering, manufacturing, both. And what you create is you get these people that not only stay in the company forever, but literally have the same approach and the same mentality. And it's not about the almighty dollar. It's about, like Eliot said, how do you engineer a piece better? And usually not, unless it's energy, how can we do more with less? I mean, when you look at these hollows and extrusions and extrusion technology in general in Europe, I mean, we do it now more here than ever. But I remember seeing these really fancy hollows and profiles where you come here and the equal system for a job that someone's bidding on, an American system was just really thick wall thicknesses, no hollows. The engineering is totally different approach.
That's an awesome one. I'm glad you mentioned hollows, because I thought about mentioning that when I was prepping for this. When I worked for a window manufacturer, we was the 10% premium for extrusions with a hollow was like taboo. You couldn't design anything with hollows back then. The die was 60% premium. They charged 10% more. And then you start going to Europe and you talk about, well, what's the hollow charge for this extrusion? They said, what's a hollow charge?
Yeah, it's the other way around. You wanted to do open-ended extrusions. They're like, oh, no, we can't do that. That's too dumb. I don't know what they used to say, but they like frowned on it.
It's crazy because they realize that they can be more efficient by putting engineering into the shape of the design instead of just adding mass and saying, well, we pay a premium. I don't know where the 10% premium came from in the first place. I think it's ancient from the old days when they couldn't extrude hollows well for architectural finished aluminum. But today, I don't think that exists anymore. And it's a holdover from 50 years ago. And we're just so used to it as an industry that we've eliminated it. And that's where not exactly where the coping came from, but it definitely contributed to the way we fabricate frames as opposed to the way they do it in Europe, because that hollow gave you the opportunity to use corner keys and make a crimped corner where, so-called solid extrusions don't really lend themselves well to corner keys, or at least not strong corner keys.
And structurally, hollows obviously are, in a layman approach, they're like trusses, mini trusses, right? So now you can have a higher functioning structural member when there's more hollows than just basically adding a lot of material to it. And the technology in this business is now starting to kind of move faster. Like the innovation is faster than ever before, and I think has to do with the telephones and computers and now this whole Vision Pro thing. It's who knows where it's going. However, make no mistake, some of the innovations and technology that was invented for this business is still the same 50, almost 60 years later. Float glass. Can someone tell me, since Mr. Pilkington himself came up with a float glass technology, who's innovated it? No one, and that's 60 plus years ago. Right?
I mean,
they still float
pyrolytic coatings.
I mean, nickel sulfide inclusions. You'd think that we can actually virtually build something 3D, but we can't take inclusions out of the float glass process. It's been around for 60 years, and it hasn't been improved. That's what it is. All right. So that's a bad example because that's one of my pet peeves of how slow that technology moves. But thermal breaks, like you were saying, leaps and bounds. Thermal modeling, coatings. All these things are really just moving forward at a speed of sound.
So the assembly of these unitized either windows or curtain wall are vastly different when you go to Asia, Europe, and here domestically. But in terms of insulated glass, it's just the same principles apply everywhere.
Yes. Yes. There is no. I mean, there is a preference, right, in different areas of the world of what one continent likes to do as opposed to another continent. It's still the pyrolytic approach is still huge in Asia. For the fact that they have machinery that does it, that the cost, the price points are different, the aesthetics aren't as demanding. All these vacuum deposition soft coats with triple silvers and all this fancy stuff. That is more of a, believe it or not, the U.S. drives that more than anybody else, because even Europeans don't, their coatings are not, the U.S. drove it because of aesthetics, but they are, with respect to insulated glass units, other than those few things, it's just the theory and the technical is the same. Nothing's changed.
So what's next?
Podcast 2.0.
Yeah, we do. How about we do glass next? Because that's kind of what I want to. I mean, it depends.
Oh
where
my
you
God,
are,
that's
but-
that's an Eliot thing. That's an hour. That's an hour. Just glass. That's an hour, right?
Well, I'm encouraged that there are changes coming like VIG, and other aerogels and things that are getting
Well, look at what
incorporated.
I mean, everybody listening to this might not be able to relate, but I don't know, AJ and Elliot, look at all the bird-friendly glass you're seeing now. I mean, that's a whole nother realm that we're dealing with, in the last 18 months?
And we're learning it. The industry is learning as we go, by the way.
Yeah, literally. Literally. So you're putting up dynamic glass, you're putting up VIG, and we're going to figure it out as we go?
Yeah, and some of it works and some of it doesn't, and ultimately, and some of it is new. What's old is new again, and what's new is old again. It's really amazing. And if I had a stick to shake at every new idea glass-wise that I've seen in my career, there's been a lot of them. And some of them are regurgitated, recycled. The ones that I think have made really big impacts on glass is what they call the iLook machine. I don't know if you guys know what that is. It's a machine that controls the optical quality of glass as it's being manufactured, right? It's literally a scanner that scans your glass for iridescence, roller wave, blah, 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 blah. That's one of them. The other machine that I think is really moved things leaps and bounds is the 3D, not the 3D, the printer, the silkscreen printer. All right, because let's face it, guys, and I think even though you're younger, you've seen what a silkscreen process is on a piece of glass, right? It's almost like making a tie-dye t-shirt, right? You take the silkscreen, you burn this pattern on it, then you put it over a piece of glass, you put the paint on it, you squeegee it through the pattern, it deposits on the surface of the glass, you send it to an oven. I mean, it's got to be a better way, right? So these printers now can get you any pattern you want on the glass with the ceramic vitrified paint. That moved the industry leaps and bounds.
Online, which is huge in the glass business because the glass industry wants to do everything online. That's why AJ mentioned pyrolytic coatings. That was an end of float line process. We used to call it value added in the old days. It was a value added product because you literally put it on the molten glass as it's coming out of the oven, and there was no secondary processing, which AJ's talking about silk screen and ceramic frit. That was secondary processing, very expensive, very time consuming, slow. It's the glass business is those machines have to run 24/7. And that's why we still do have nickel inclusions, because no one wants to take a float line offline to clean it. And that's where
I actually think
come from.
Eliot, what do you think? You said what's next? Big topic through my entire career that always rears its ugly head is the whole heat soak thing, right? And how expensive it is. And you're laughing because you know exactly what I'm talking about, Adrian, right? Then we talk about the 7 and 1,000. Then we talk about, well, if I have to replace this glass, and the owner gets involved, and then it's money being thrown around. And I mean, I'm not an accountant, but it makes my head spin, right?
Yeah,
Can we
like you come in?
Yeah, and it's a double handling issue, right? It's a double handling when you heat soak, right?
More than double.
Triple, quadruple.
It's laminated, coated, so it's handling things 16 times now, and the
That's
chances of defects go up. But that's where you guys, as the facade experts, come. I talk about this. I post on LinkedIn about this. But anyone who doesn't hire a good facade consultant today is out of their minds, because it's so much more complicated today than it was even 20 years ago to build a facade, to build a skin that performs correctly. People think that it's just putting up sticks, rolling on a waterproofing, throwing brick on top of it, putting a window in it. It's not. The requirements to get things right are so high. You have to balance so many things that we never used to have to do. As long as the wall didn't leak, we were golden 20 years ago. Today, it's got to perform thermally. It's got to hold out air. Nobody cared about air 20 years ago. We didn't care about air leakage. There wasn't even air barriers. It wasn't even required. There was no building code. So there was no air barrier part of the building code, or not building code, but energy code, or it was a fledgling energy code.
Bird glass, light pollution. I mean, you got a whole bunch of stuff going on these days.
Yeah, I'm happy you brought up heat soaking. And the other one that I'm saving for next podcast is weep holes, which I know the two of you will love to go back and forth on.
Why? Do you like them or hate them? Not you.
If it's necessary or not.
It all depends on the system. It depends.
This is where it's going to get good, right? Because if you get one answer on one side and a different answer on the other, we got something going on.
We'll have
right?
some fun. All right. Well,
heat soaking is important to talk about, but on the next podcast or whatever you want to do. I mean, now that
We had to convince him to do this one, and he's
You know,
already
now
ready
that
to
he
do
get
the
now
next
that he
one.
gets it, we're
No,
saving
no,
it
I'm
for
done.
show.
I'm done. You're really gonna have
No,
to
you're
promise me the
not.
next
You
one.
just committed to it. We heard it.
That's why I
it's
stopped myself.
recorded
I don't know if you noticed. I
4:30.
stopped half sentence. I was like, oh boy.
No, you didn't. No, you didn't.
All right, thank you for the two of you for hopping
It
on.
was a lot of fun. I mean,
it
and
was.
being with Eliot's always a lot of fun. Adrian, not so much with you, but
Well,
I
let the
still
two of
have
you do
I
most
still
of the
have fun
talking.
with you.
All right, thank you both. I'll talk to you
All
next
right.
time.
You're very welcome. Have a good weekend.
Bye, guys.